Thank you for having me. Before I'm going to explain what 2226 is, maybe we have a little history lesson. I guess architects forgot how to build efficiently and sustainably. In Europe, we knew how to build really massive and very sustainable buildings. I personally grew up in a very old building which was realized in the 16th century, so really massive walls of 1 meter of granite and very reduced glazing area. And in the summer it's always cool, it's very easy, it's very nice. But in the 70s we started to build really cheap. Probably during the oil crisis, we technicalized our buildings very much. My background is in MEP, and even I don't understand all the pipes that are going through buildings, unfortunately. In contrast to this is 2226. If we look at this building, and this is in Lustenau, Western Austria, and it has no heating system, no cooling system, and no mechanical ventilation. And even though we don't have any of these systems, the indoor temperature is between 22 and 26 degrees. It's based on very easy physical principles that we all know, and they're quite easy to understand. The idea was born by Professor Eberle around 25 years ago, and when he had a lecture, one of his students put his hands up and was like, why do we buildings with so much technology inside? It should be possible to realize at least office buildings without these systems. And well, then the idea was born, and Professor Eberle thought a lot about it, and this was then the first prototype and the first project that was realized in this way. It has a very compact shape and size. It's 24 by 24 by 24, and the materials, there are not a lot of them. It's made from brick, it's wood for the window frames, it's glass, and it's concrete. So there are not a lot of materials. And this building was not done for 30 or 50 years. If we look at the life cycle of buildings, they're always calculated around 50 years, in Switzerland 60 years, and this is much too short. And if we look at buildings nowadays, they have a use sometimes of 30 years, then you can't reuse them, they're so technologized, and then you have demolished them. And this is an ecological and economical disaster, of course. And this is why we're doing this now. And we've really reduced systems, but still the strategy is to increase comfort inside the buildings and to reduce the energy demand, which is of course good for carbon. If we look at this picture now, this slide now, the principles, it's a holy trinity, let's say, or a trifecta. It's made of building structure, it's a question of quality, and the operating system. So the operating system, just to give you a buzzword, we replace hardware with software. But if you go to the building structure, in order to help or to create such buildings, you need massive materials. They need to have quite a lot of heat capacity. For example, concrete has this, ground earth has this. We don't have any suspended ceilings. For example, we don't have suspended ceilings like this because we need the energy to radiate off the ceilings and the walls. And quality is quite important. We do not have any external sun shading in this building. We have deep reveals. If we look at on a building on the south side, the sun is about in the south about 68 degrees on top. So it's really, really steep. And if you have reveals, you don't need sun shading, of course. You get more daylight, which is much more comfortable to work with, also to live in, to be honest, at least I do. So we want to reduce artificial lighting. And then, of course, the materials are quite important because they have to be durable. It is not good to replace materials every 30 or 40 years, and also technical systems have to be replaced every 50 to 30 years. This comes back to your speech before. With maintenance costs, you don't need to maintain much in this building. And then, of course, there's the operating system, which is, so to say, the brain of the building. As I said, we do not have any mechanical ventilation. We use natural ventilation. This is what we all know. We open the windows when the air gets bad inside, and we just automate this. So if the CO2 inside the building rises above a certain threshold, then we open the windows. Cool air gets in, or warm air gets in, depending on the weather. It gets stored, in the thermal masses, concrete or rammed earth, for example, it radiates off again. So we always have a really good air quality inside, even though we do not have any mechanical ventilation. Just to give you a funny example, if any one of you has ever been in Dubai and you walk into these high-rise buildings with glass facades, if the mechanical ventilation stops for just an hour, all the windows will have condensation on it. This is horrible. This is not good in my opinion. I'm going to show you now a project in Switzerland, which is done by now. It's a hybrid building because on the ground floor and first floor there are laboratories, but all the upper floors are Q22, 26, so without any technical systems. And if you look at this graph now, on the left-hand side, unfortunately in Germany, it's the primary energy demand from non-renewable energy sources. On the right-hand side, there are carbon emissions. And the red graph was the goal from Switzerland for 2040. And you can see the yellow graph, we even topped this, fortunately enough. So this building performs in primary energy demand better than was expected in 2040. Oh, by the way, renovation, I have to make a short statement. Even if we triple our efforts to renovate buildings, it doesn't make any change for the climate goal 2050, unfortunately. We even have to top this. But yes, such buildings, if they are built for more than 100 years, and this is our goal, they perform quite well in this regard. And now we come to materials. Lustenau, so the first project with 2226, is, as I said, quite simple. It's just made of bricks. So the envelope are 2 layers of bricks, and there's the concrete ceiling. But we don't need to use bricks, for example. In the middle, you can see a project in Luxembourg right now. And this is the facade is made from prefabricated wood, straw, and clay elements. So it was quite fast to build. It's very nice to be inside, and it's sustainable, I guess. On the right hand side is a renovation. Unfortunately, not a picture of inside, but on the top of the ceilings we put clay plasterboards, which are quite good for indoor climates. So we are not dependent on bricks or concrete, but of course concrete is very good values in our property. I have to say this. And this method of building is adaptable to all topologies. We have done housing projects, social housing projects, affordable housing projects. We've done offices, of course. Offices are probably the easiest one to do. Education. We've done a university in Vienna by now. And of course renovations, which is quite important to do now. And we need to renovate more. As I said, we need to more than triple our efforts to renovate buildings. Just to give you a short overview of what we have done and what we are doing so far. If you go to schools, on the left-hand side is a kindergarten in Leipzig in Germany with this method, with natural ventilation. And of course there were some problems with regulations because you need to have a certain CO2 threshold inside for the children, which is quite a challenge. In the middle there's a social housing project for really low-income families. On the right-hand side is a classical office building, which looks almost like Lustenau but in green in Belgium, in Kortrijk. Yeah, quite small. The kindergarten is a bit bigger. And then some larger ones in Lyon, Conflans. It's a new development area in Lyon. And one of the housing projects there was 2226. And again, the Edinburgh project in Luxembourg with these straw, clay, and wood prefabricated facades, which is a private client. And on the right hand side for the SNCF, the French train company, a really large office buildings for them, which is also by Geneva. It's quite hot there. Yes, I guess this was the really short version. I could talk hours and hours, but I have to keep it 10 minutes, so and I'm always at the end of time. So thank you very much, and please feel free to ask me challenging questions.